Hi guys, welcome to the Linear Regression Project Overview lecture. In the previous lecture, we have successfully developed a linear regression model to predict the house price in Boston area based on the given features. Now, we are going to work with another real dataset on health insurance cost prediction. The situation is you are hired by an insurance company. The company is working in United States and want you to develop a model which automatically predicts the health insurance cost for their customers. You are given a data set which has the following columns: age of the primary beneficiary, sex, female and male, BMI, body mass index, children, number of children covered by health insurance or number of dependents, smoker, yes or no, region, the beneficiary's residential area in United States, which is divided into northeast, southeast, southwest, and northwest, and charges. So the charges column is actually the target column based on all the features in the list, which is individual medical cost billed by health insurance company. Let's have a quick overview on the tasks that you are planning to perform. So the first thing first, as always, you have to import the following libraries. So simply run this cell and import pandas, numpy, matplotlib, seaborn, and set matplotlib inline. The first task is please load the dataset into pandas data frame and output the head of the data. It should be pretty simple now, and the output is given. So you need to load the dataset and display the head of the dataset. The next one is, notice the smoker column is yes or no. So here we have smoker, yes, no. Create a new column where you will have 1 for yes and 0 for no. Hint is, you need to write a function for this task. So what you need to do, you need to grab the smoker column, and if you find yes, put 1 in the new column, and if you find no, you need to put 0 in the new column. It will be a good revision for Python Essentials and should be very easy to write this function at this stage. So moving forward, could you please write a function that returns 1 if BMI is greater than 30 and 0 for all other BMI values. Once again, you need to write the similar function as you are going to write for the smoker column. So the next one is, notice the sex column is male, female. Create a new column where you will have 1 for male and 0 for female. Once again, the similar function that you are supposed to write for the previous two questions. So moving forward, now you have a couple of new columns in your data. Check the head of your data frame once again. So these are the new column that you will create in the previous tasks. Moving forward, how many observations you have in your data. Also display the basic statistics of your data frame. Hint, use info and describe. Should be very easy, you just need to call these two functions on your data frame. The next task is, please output the list of columns in your data. So this is the list of columns in your data frame after adding new columns. You need to display this list now. Next is exploratory data analysis. You need to create a couple of plots now. It's always good to learn more about the data. So recreate the plots below. Notice the mean charges along y-axis in right plot, these ones here. Hint, you can use seaborn's bar plot method. So you need to recreate these two plots. So the next task is, please recreate the plot below. So you have to recreate this plot. You have children along x-axis and count along y-axis. Moving forward, please recreate the plot below. And hint is kind equal to reg. So you have to recreate this plot and notice the joint grid here. It should be a good hint for you. So the next one is recreate a heat map for correlations. You have to recreate this map and put the correlations on the map as well. So moving forward to the machine learning part, separate data into X and Y arrays. Use age, BMI, children, smoker norm, obese for X and charges for Y. The next is import train test split and split the data into training and test datasets. Use test size 0.33 and random states 101. If you use the same numbers, you will find the same answer what is given in the solution lecture. So the next one is check the head of your X train. So you need to display the head here. Import linear model is the next task. Should be very simple to import linear model from Scikit-learn. And the next task is create an instance for linear regression model. You know the linear regression model is a part of linear model family. Here you need to create an instance for linear regression. The next task is train your model on X train and Y train. And then what is the value for the intercept? The next task is what are the values of your coefficients? So you need to display these coefficients for each feature that you're using to train your model. Create a data frame using columns from X as index and values of the coefficients in a new column coefficient. Although it is optional, but it is always nice to display your results in better ways. So the next one is our model have never seen X test. Let's provide test data X test to our created model and see what the predictions are. Once we get the predictions from the model, we can compare them with what we have in our Y test. So now you have to deploy your model on X test and see what predictions you are getting from your model. Moving forward, generate a scatter plot below. Now you have the predictions and you know the observed values. Generate a scatter plot for predictions and observed values. The next one is recreate the residual histogram given below. Hint is Y test minus predictions. It should be very simple to recreate this residual histogram now. The next task is print MAE, MSE, RMSE. So mean absolute error, mean squared error, and root mean squared error. You need to import matrices and then display these values in the output. I hope these tasks will be pretty simple for you. Before we move on to the next lecture, try to solve these tasks yourself. Anyhow, see you in the next lecture where we are going to solve these tasks one by one. Good luck.